Hi dear students, this is me Ishfaq Riyaz, and today we'll be discussing one more topic on vectors, that is triple product of the vectors. So far we have discussed the cross product of the vectors. If you remember well, the cross product between two vectors, let me consider two vectors B and C here. We have defined the cross product of the two vectors, that is simply a vector whose magnitude is equal to magnitude of B magnitude of C into sin theta. और आपको ये भी पता है this is also a vector, rather it gives us a third vector and whose direction is perpendicular to the plane containing B and C. और आज का जो हमारा टॉपिक है वो है basically triple product of the vectors. If this product, I mean this vector, since this is a vector, so we can multiply this very vector with a third vector A. Either we can multiply it by dot so as to get a scalar quantity, or we can multiply this very vector with a third vector C by using cross so as to get a vector quantity. This product, since this gives a vector quantity, so this will be called the vector triple product. And this very product, that is the product, rather the dot product of a vector, rather third vector A with the cross product of the two vectors B and C, it gives a scalar, and hence this is called the स्केलर ट्रिपल प्रोडक्ट. और आज का जो हमारा टॉपिक है वो यही है, दैट इज स्केलर ट्रिपल प्रोडक्ट. सो लेट मी राइट हियर एसटीपी, दैट इज स्केलर ट्रिपल प्रोडक्ट ऑफ द वेक्टर्स. एंड हाउ डू वी डिफाइन इट? इफ आई हैव टू वेक्टर्स B and C, and if I take the cross product of these two vectors B cross C, and you already know this gives a vector quantity. If this vector quantity is multiplied by a vector A with the help of this very dot, I mean if we take the dot product of a third vector A with the cross product of the two vectors, that is B and C, since this is a vector, this type of the product, since it gives a scalar quantity, this is called the scalar triple product, because the product here is between the three vectors A, B and C, and we usually denote this scalar triple product by this. This is A, B and C. This indicates that this ABC is basically equal to A dot of B cross of C, right? So this is the definition of the scalar triple product. Now what does it indicate basically? What is the geometrical significance of this STP? Geometrical significance of STP, that is scalar triple product. What does it basically represent? Let me draw a parallelepiped here. Are you familiar with the figure parallelepiped? Just like square in 2 dimensions, it is related to cube in 3 dimensions. Rectangle in 2D, it is related to cuboid in 3 dimensions. In the same way, parallelogram in 2D, it is related to the parallelepiped in 3 dimensions. Let me draw a parallelepiped here. So, this is a parallelepiped. Let this be vector B, I mean let this be O, let this be point B. Suppose this is vector B. Suppose this is vector C, let me name this OP, Q, R, and suppose this is T here. Sorry, suppose this is T here. So let this be vector B, let this be vector C, and this is a parallelepiped, right? Okay, now as per the definition, what is this B cross C? Rather the magnitude of B cross C equal, आपको पता है from geometrical interpretation of cross product, this B cross C, rather the magnitude of B cross C, it is basically equal to the area of parallelogram O, P, Q, R, right? और आपको ये भी पता है B and C, they are the adjacent sides of the parallelogram, right? And this is basically a vector which is perpendicular to the plane containing B and A. Suppose this is N, so this will basically represent a third vector, let me call it D, that is basically equal to B cross C, right? Okay, suppose this is vector A, and the angle between vector A and this vector D, suppose this is equal to theta. So magnitude of B cross C it is equal to the area of parallelogram OPQR. I mean this very parallelogram. Now in order to calculate the volume of the parallelogram, we have to multiply this area by height. So let's calculate the volume of parallelepiped. Volume of parallelepiped, that will simply be equal to area of parallelogram OPQR into the perpendicular distance of this very plane, I mean OPQR from T. I mean this very perpendicular distance. Let me call this distance as H. This is the perpendicular distance of this plane from T. Okay. Now, can I write this perpendicular distance? ये जो H है, ये basically H जो है, this is projection of vector A on ON. So I can also write this perpendicular distance basically H जो है, ये यहाँ पे मैं लिखूंगा, this is projection of vector A on ON, right? So this is projection of A on ON. क्या आप बता सकते हो इस right angle triangle में this projection basically? Let me call this OPQR, let me call this OS. This OS is the projection of OT, that is vector A on ON. I mean on this very vector D, that is equal to the B cross C, right? So this is equal to area of parallelogram किसके बराबर होता है? Magnitude of B cross C, simply. Now what is the projection of this very vector on OS? In this very right angle triangle, you can easily see this is equal to A cos theta, this very component OS. So I will write here, this is equal to A cos theta. See, this is magnitude of A, magnitude of B cross C into cosine of the angle between these two vectors. What is this equal to as per definition? This will be simply equal to A dot of B cross C. Remember the definition of dot product. A dot B equal to AB cos theta. Here magnitude of A, magnitude of B cross C into cos of theta. So this will simply be equal to A dot of B cross C. What does this basically represent? This A dot of B cross C, it is nothing other than the scalar triple product, right? So the geometrical interpretation of this very scalar triple product is simply, it is equal to the volume of the parallelepiped, this whose sides are given by three vectors, that is vector A, vector B and vector C, right? So this is the geometrical interpretation of STP, that is scalar triple product, simply equal to the volume of the parallelepiped whose sides are given by three vectors A, B और C. ठीक है ना? और आपको ये भी पता है since this is dot product, so it is positive if theta is acute, and the scalar triple product it is negative if theta is obtuse. Now let us try to write few more properties of scalar triple product of the vectors. As per definition, scalar triple product is basically a scalar quantity equal to A dot of B cross of C. Now the property first of this STP is that if three vectors, I mean if vector A, B and C, if the three vectors are coplanar, what does this mean? These three vectors are acting in the same plane, or they lie in the same plane. You can easily see it from this very parallelepiped. You can easily see it from this very diagram. If this is B cross C lying in one plane, B and C lying in one plane. Now, if this vector also lies in the same plane, will they form a parallelepiped? No. In this very case, the scalar triple product it will be equal to 0. I mean volume of the parallelepiped it will be equal to 0 because the three vectors are coplanar. So we can conclude that if the three vectors are coplanar, then their scalar triple product it is equal to 0. So A dot of B cross C it will be equal to 0 if the three vectors, I mean A, B and C are coplanar, that is they are lying in the same plane, right? So this A dot B cross it will be equal to 0. Conversely, मैं अगर आपको ये कहूँगा कभी कभी आपको क्वेश्चन आता है prove that the three vectors are coplanar. You will simply show if the scalar triple product is equal to 0, then the three vectors are coplanar, right? Now let's move to property number 2. If any of the two vectors are parallel, let me consider here. Suppose B is parallel to C. suppose B is parallel to C. Okay, now as per the definition of cross product, B cross C, it is equal to magnitude of B C into sine of the angle between the two vectors. Now if the two vectors are parallel, what is theta equal to? 0 degree. और आपको ये भी पता है sin 0 is equal to 0. 0 into something is 0. So B cross C, it will be equal to 0. What about the scalar triple product? Again you can see if this very term is 0, 0 into something is equal to 0. So again we will get A dot of B cross C, it will be equal to 0. So if the two vectors are parallel, rather if any two vectors are parallel, then their scalar triple product is equal to 0, right? Now one more property of this very scalar product is that if the two vectors are equal, let me write property third here. If the two vectors are equal, any two vectors, if two vectors are equal, I mean, let me suppose here, suppose vector B, it is equal to vector C. If two of the vectors are equal, I mean vector B is equal to vector C. Let me again calculate B cross C here. B cross C. Let me write it, since the two vectors are equal, so let me write it B cross B. आपको याद ही होगा, मैंने क्रॉस प्रोडक्ट में भी आपको ये प्रॉपर्टी बताई. What is B cross B equal? This is magnitude of B. Magnitude of B and sine of the smaller angle between B and B. और आपको ये भी पता है, the angle between B and B, it is equal to 0 degree. So sine 0 is 0. Again this term will be equal to 0. Now you can see, if the two vectors are equal, again their scalar triple product is equal to 0. So A dot of B cross C, it is again equal to 0. So if three vectors are coplanar, STP is equal to 0. If two of the vectors are parallel, scalar triple product is equal to 0. And if two of the vectors are equal, then again the scalar triple product is equal to 0. Now let's try to find out the scalar triple product of orthogonal unit vector triad. So property 4, scalar triple product of orthogonal unit vector triad. Unit vector triad. I mean, if I am supposed to calculate I dot of J cross K, right? Now, as per definition, so this is equal to I dot of. Now, as per the properties of cross product, याद है ना आपको? ये किसके बराबर होता है? J cross K. Remember the cyclic order of these vectors. This is equal to basically I. Remember, J cross K, that is equal to I. Now I dot I, it is equal to 1. You remember this very property, I have already used this in dot product of the vectors. So scalar triple product of orthogonal unit vector triad, it is equal to unity, that is 1. Right? Now one more property of the scalar triple product is that it is independent of the position of dot and cross. What does this mean? Let me elaborate it here. Scalar triple product is independent of the position of dot and cross. What does this mean? Simply if we interchange dot and cross, STP, I mean scalar triple product remains unchanged. So this basically A dot of B cross C, dot के बदले में cross लिखूंगा, so this will be equal to A cross B, और cross के बदले में dot लिख सकता हूँ. So A dot of B cross C is equal to A cross B dot C. So scalar triple product remains unchanged if we interchange the dot and cross, right? So I can simply write A dot of B cross C, this will be equal to A cross B dot C. ठीक है ना? Okay. एक और property scalar triple product की, as long as the cyclic order of the vectors remains unchanged, their scalar triple product also remains unchanged. Now let me explain it here. What does this mean? That is, if I write this is A dot of B cross C, as long as the cyclic order, that is cyclic order here it is, for example, this is ABC, then I can write BCA, then I can write CAB. Again by using the definition, that is STP, scalar triple product. So if the if the cyclic order of the vectors remains unchanged, then their scalar triple product also remains unchanged. मैं बताता हूँ what does this mean. A dot of B cross C, it is equal to B dot of C cross A, it is equal to C dot of A cross B. This is the cyclic order. You can see A, B, C, then B, C, A, then C, A, B. If the cyclic order remains unchanged, then the scalar triple product remains unchanged. You can also verify this result after this very property. I mean, मैं आपको एक और property बताने जा रहा हूँ. Then you can verify this result. That is basically the property is when we write the scalar triple product in component form. So let me write here the property 6th. That is scalar triple product in component form. So property 6th, in component form we can write the scalar triple product is, और आपको पता ही है कैसे हम लिखते हैं ये जो तीन वेक्टर्स है in terms of rectangular components, we usually write them AXI plus AYJ plus AZK. Or let me write vector B, it is equal to BXI plus BYJ plus BZK. And vector C, it is equal to CXI plus CYJ plus CZK. This is basically the representation of a vector in terms of its rectangular components, right? Now, we are basically discussing the scalar triple product of the vector. So, in terms of the rectangular components, we will simply write ये जो scalar triple product है A dot of B cross C. We can simply write it in determinant form. Basically like this. This is AX, AY, AZ. This is equal to BX, BY, BZ. This is CX, CY, CZ. So in component form, we can simply write A dot of B cross C, it is equal to the determinant of this, that is X, AY, AZ, I mean the coefficients of I, J and K, forming the rows and the columns of this very determinant, right? Now, you know the properties of the determinant and how to elaborate, how to evaluate this determinant basically along R1, or you can also expand it along, can also evaluate it along row first or R1 or column first. And आपको ये भी पता है the properties of the determinant basically. If we interchange two rows or two columns of a determinant, then the value of the determinant remains unchanged but changes in sign. But if we simultaneously make two exchanges, I mean if I change this to this, then this to this, the value of the determinant remains unchanged. इसलिए मैंने इससे पहले आपको property बताई, the scalar triple product remains unchanged as long as their cyclic order remains unchanged. क्यों? You can verify this by this very determinant. ये जो determinant है, it is also equal to, अगर आपको याद होगा अभी मैंने आपको बताया, ये जो है A dot of B cross C, it is also equal to B dot of C cross A, that is also equal to C dot of A cross B. Why? Because we can write this determinant in this very form as well. We can write this is BX, BY, BZ, then CX, CY, CZ, this is equal to AX, AY, AZ. Not only this, it is also equal to this very determinant, that is CX, CY, CZ, this is equal to AX, AY, AZ, and BX, BY, BZ, because the value of these very determinant, because the value of these three determinants remains unchanged. So that is why I said in the earlier property that the scalar triple product remains unchanged as long as its cyclic order remains unchanged. So these were some of the properties, rather this was the definition of the STP scalar triple product. It is geometrical interpretation and few properties of this very scalar product. So let me revise the things in glance which we discussed today. Simply I started from triple product of the vectors, that is simply the multiplication of the three vectors. Then if I multiply the cross product between two vectors, I mean B and C, with the third vector, we can either get a scalar quantity or a vector quantity. If I use the operation dot, I will get scalar quantity, and that very product is called the scalar triple product, which was our topic to discuss today, right? And if I multiply it, that scalar, rather the vector product of two vectors by a third vector A, by using cross, we will get a vector triple product, right? That we will discuss separately. So our topic today was scalar triple product. Then the geometrical interpretation of this very STP, I mean scalar triple product, it is simply equal to the volume of the parallelepiped whose sides are given by the three vectors. This is vector B, vector C, and this is basically the vector A. Three sides of a parallelepiped starting from O, right? So this was the geometrical interpretation. After this, we discussed a few properties of STP, that is, if two vectors are equal, STP is equal to 0. If two of the vectors are parallel, STP is also equal to 0. You can say if any two vectors are parallel or any two vectors are equal, you can verify that very result here. मैंने पहले कहा था if B is equal to C, you can here see if C is also equal to A, then STP is 0. If A is equal to B, then STP is equal to 0. Or if two of the vectors are parallel, मैंने पहले कहा था if B is parallel to C, you can here see it. If C is parallel to A or A is parallel to B, then STP is equal to 0. Then the scalar triple product of orthogonal unit vector triad, that is equal to unity. And this STP, it does not depend upon this position of these. If their cyclic order basically remains unchanged, I mean as long as cyclic order remains unchanged, the STP remains unchanged. And one thing more, we can replace dot by cross, just like A dot of B cross C is equal to A cross B dot C, right? So we can interchange the dot and cross. और जो last property मैंने आपको बताई, that is basically the scalar triple product in terms of components. We can simply write this A dot of B cross C in terms of a determinant, and this determinant will always give you a scalar quantity. And by using the properties of the determinant, like interchange of any two rows or columns, or if we can make two interchanges, then the value of the determinant remains unchanged. We can verify this, that is scalar triple product remains unchanged as long as its cyclic order remains unchanged, right? So this was all for today's lecture. Hope you enjoyed it very well. Hope you enjoyed it very much. Thank you very much.